Welcome to the fourth installment of creating the Osmosis solitaire game using Tkinter. So, a quick review. We have a module called Cards, and Card contains two classes. There's a Deck class and a Card class. Remember that the Card class is just used to store images for each card, and those are based off the suit and rank of the card, obviously. And then the Deck class contains the color of the deck. It contains an ordered list of the cards, which we can then sort, and then it also contains a dictionary, which can get us, for any suit and rank, a copy of a card. So basically, this is how we get an image file, is using an ordered pair. In fact, a lot of things in this program are based off from these ordered pairs that come from this original ordered list. And notice I have this printed out down below. We've seen this list before in video 2 when we looked at these different classes. So this is it's a big list. It's a list of 52 ordered pairs for all the classes. And then the other list that we've talked about before, the played list, the kitty list, and the stack list, we're going to see are built actually from this original deck list. So when we are playing the game and we double click here to put cards into the kitty, in terms of lists, we are just going to pull ordered pairs off from the deck and put them onto the stack. So the stack is going to be full of these ordered pairs. And then when we deal cards in the kitty, we're also going to deal those off from the deck, so more ordered pairs, and those are going to go into the kitty. And then when we play cards from the stack and the kitty, things in here are going to go into the played list, so the played list is all going to be ordered pairs. So all of these lists are built from this original list of ordered pairs that represent a card. Okay, also keep in mind that we have a list of corners of rectangles. That is not a list, did I say list? Dictionary. The keys for those dictionaries are addresses on the table: deck, stack, K row 1 through K row 4, and P row 1 through P row 4. We have a separate dictionary for where the cheats are stored, and it's important to know that when you click on the deck, click on the table, this method where clicked is called, and where clicked returns a position, and that position is one of those key values from the corners dictionary. So a position is going to be given by one of those keys. Okay, so what I want to look at now is how we actually place cards on the deck and on the table. I keep saying deck. How we place cards on the table. So place card is used to place cards on the deck, the stack, the kitty rows, and the played rows. It doesn't place cards up here, again, because the cards up here in the cheat section, the addresses are stored differently. I stored those as centers and not as corners, so the code would have to take into account that, and I didn't do it. Maybe I should have. Maybe I should change the code for place card to also place the cheat cards, but we'll can look at that later. Okay, so for place card, we get a card tuple. So that's one of these, and we get a position, and again, the position is one of the keys for the corners dictionary, so deck, stack, K row, etc. Okay. Now, once we have the card tuple, we plug that into the deck, and what that does is that gets us a card, and that card is then one of these. So card in this case is literally of a class card. So that has an image associated with it, among other things. And now we want to know where we're going to place this card. So initially I take X and Y to be the average of the X coordinates in the corners and the Y coordinates of the corners, and there's an obvious reason for that. To do that, if you take the average of the X's and Y's, that puts you smack dab in the middle of where we're trying to place the card at, which in most cases is exactly what we want to do. So for the deck, the stack, and the kitty, that's exactly the right X and Y. But when we're placing a card in the played row, there's a couple of things we want to take into account. First, if we just average the X's and average the Y's, we're going to end up placing a card right here in the middle. So even the very first card would be placed in the middle of this played road. And that's not what we want. But then there's another thing we have to keep in mind. We're going to be playing multiple cards in this played road, and we want to see all of them, which means that where we place in the played row is going to depend on what cards have already been played. So the Y value is still easy to compute. That's just the average of the top and the bottom. So we're going to go ahead and keep that. And it's nice, again, that we're able to easily pick off these corners from the dictionary because position just, well, keys us right into that dictionary. So no problem there. But if the position happens to be one of the played rows, now, again, the positions can be stack, deck, K row 1 through K row 4, P row 1 through P row 4. So how can we tell if the position is one of the played rows? Well, the string P row will be in the string position. So if that's the case, then we're going to have to figure out how many cards have already been played and what row are we in. So to get the row, so again, position is going to be, in this case, would be P row 1 through P row 4. The 1 through 4 would be the last index on that string. So I'm going to get the last index. That's the length of that string position. Subtract 1. Plug that into position. That will give me the last character in the string. That should be an integer, so I'm going to convert that to an integer. Now, perhaps I should put this in a try except block because I am converting a string to an integer, and in theory this could fail, but it's not going to because I have coded this properly, I suppose. I want to make this into a row. Now, this row I'm going to put inside a list. So row really should go from 0 to 3, but remember this is P row 1 through P row 4, so I'm going to subtract 1 off the integer I get, and that will give me a correct index into a list. So now that I know which row I've clicked on, so now row would be 0 for this row, 1 for the second row, 2 for the third row, and 3 for the fourth row. Now that I have pulled off the row information off from this address, then I can figure out how many cards are in that row. So I just look at the length of the played row. And now, since we're going to be placing a card in there, then I'm going to go ahead. Now, this is not checking if the card should be placed in there. That's a different matter. This is just assuming we've already done all the checking and just playing it. So in this case, I'm going to go ahead and place the card in the played row. So I'm appending the card tuple to the played row. Remember, this is how we keep track of the list. It's all in terms of these tuples down here. So I append that card tuple. That card tuple will have been removed in a different section of the code that actually is responsible for the playing. Okay. And then in this case, what do I want X to be? Well, I want to start off at the left coordinate of the played row. So I'm going to position left X. I'm going to add half the deck width, so that will put me in the center of a card. Add a little bit of internal spacing to space me over a little bit. And then I need to move over the number of cards in the deck. And remember the not the number of cards in the deck, the number of cards in this row, which we called num cards. So I multiply num cards, number of cards in this row, times the deck width, and that gives the proper spacing. And then we are going to place this on the table, and the table is a Tkinter canvas. So we use the canvas.createImage method, place it at X and Y. The image we're going to use is, remember that card was from the card class, so it's just card.image. And the tag, remember we set this up, this card class had a string method which returned a concatenation of suit rank. So the tag we can just tag with string card. Now, one of the things I hope to accomplish in making the solitaire game is to review a lot of different things that we have already done. So I set up this card class specifically for this method so that it just worked kind of nicely. So we have this card class that it can immediately invoke. Setting up the image is just card.image. Setting up the tag, it's just the string of the card. It just works nicely because that card class was set up to do basically this. In other places, we're going to use different techniques. Okay, so now that we have place card, we can go ahead and deal some cards. So we want to deal cards, then the first thing we're going to do is shuffle the deck. So that is a method that comes from the deck class. And then we need to place cards in the kitty. And well, we need to place cards two places. We need to place cards in the kitty, and we need to place a card on the deck. Now in the kitty, we need to place one card here, two here, three here, 4 there. So I'm going to run 2 for loops. The first for loop is going to go from 0 through 4, and that's going to give us the start row. So when the start row is 0, we're going to place cards in all 4 rows. When the start row is 1, we'll start at this row and place cards from there. When the start row is 2, we'll start here and place cards. When the start row is finally 3, we'll only place in the last row. So this inner loop right here is actually controlling the row that cards are being placed in. And notice that it starts at start row, as I was saying, and goes up to the last card. So hopefully that makes sense. And then what we're doing here is we're not actually putting the cards on the table yet. We're actually making the kitty list. So we go to the row of the kitty, and we append to it the card from the deck. Remember, the deck is self.pack.order. We find the last card in the deck. So the last card in the deck is the length of the deck minus 1. Plug that in, and we get the last card on the deck, self.pack.order. Again, this is going to be one of these tuples. And in the very first case, after it's been shuffled, it would actually be the 7 of clubs right here. We're going to append that to the kitty. And then on this on the deck, self.pack.order, we're going to do what's called a pop. Pop basically says, oh, this is a list. So this thing is a list. That's our deck. Take the last thing off from that list. So after we do pop, this will be removed and will be on the kitty list. So again, we go through the entire kitty and form the kitty list, and then when we're done, what we want to do is then place the card that's on the top of each row of the kitty. So we're going to again go through the rows, 0 through 3. We're going to get a position to pass into place card, but the position's a string, so it's going to be K row, and then on the end of K row I need to add the row, but in this case the row has to be 1 through 4, right? So we take the row, 0 through 3, add 1 to that, make that into a string, append it to K row, and off we go. We place the card at the position, and which card do we want to place? Well, we want to go into the kitty at the correct row and find the very last or very top card on the kitty. How do we get the top card in the list or the last card in the list? We take the length of that list, subtract 1, and plug it into the list, and that gives us the last card for each row. So this technique of getting the last card in a list or last thing in the list, we've used quite a bit here. And then the last thing we need to do is place a card on the deck. Well, the card we're placing on the deck is actually the down card. The card is, well, face down. Remember that the down card was actually built into the deck. So that is one of the attributes of the deck, the down card. And so we place the down card. This gives us the image, and this is where to place it. So that's the deal right there. Once we had, place card set up and the dictionary for all those corners of the rectangles, this actually wasn't too bad, I don't think. Okay, let me see how much time we got. I want to see if I have time to go over this cheat bit.